This video will deal with the endogeneity problem according to the plan above. With the OLS method, assumptions of Gauss-Markov have to be respected in order to work with reliable OLS estimator. One of them, called the exogeneity, said that there should have no relationship between error term and an explanatory variable. When this independence is not appreciated, the model suffers from endogeneity and the OLS estimators are biased and inconsistent. There are several sources for endogeneity problem, but in this video I will only explain the three main ones. First, the omitted variable bias arises when we omit to include in the fitted model a relevant explanatory variable. Assuming, for example, that the true model is this one and that the estimations are based on the following fitted model, the omission of x3 in the model will bias the estimator and will invalidate some test. Indeed, in addition to its direct effect, x2 has an apparent indirect effect because it acts like a proxy of x3. So, the expected value of b2 is biased as follows. Concerning the proxy effect, its power depends on two factors, the effect power of x3 on y and the ability of x2 to imitate x3. The second cause implies that the original explanatory variable cannot be observed without error. Assuming that we have to estimate the following model, but that in reality we cannot observe z alone because a measurement error is associated to it. We can only observe x. Under this condition, x will become the observed explanatory variable in the regression model. Using the OLS method to estimate this model will provide bad estimators because the error term is not independently distributed of x. Indeed, x depends on w, but u is also impacted by w. So, the estimator of beta will be inconsistent and in larger sample b is biased. The third cause of endogeneity occurs when two variables influence each other. To illustrate this, we will take the following model, and when we put the equation of y in the z equation and after manipulation, we obtain this equation. Based on this transformation and on this assumption, we can prove that in the equation of y, there is endogeneity problem. The first term is 0 because x1 is exogenous to u. The two second terms are also 0 because x2 and v are had from the z equation and so exogenous to u. Finally, the last term is different from 0, otherwise if delta 2 is 0, there is no simultaneity anymore. With the presence of endogeneity in the model, other methods should be used to obtain reliable estimates like the use of instrumental variable. In this model, we can solution the problem of the inconsistent OLS estimators by taking a proxy of x, for example z. This instrumental variable has to satisfy the exogeneity condition and the relevancy. By replacing x by z, the new estimator is the following one. The estimator is biased, but the bias can be neutralized thanks to this multiplication. This ending new estimator with z is called the estimator 4. Because of the link between u and x, the estimator remains biased, but it's convergent because when the number of observations in the sample increases, the bias is less important, and so the estimator 4 are better than the OLS 1 when the model is facing endogeneity. The 2SLS method is in continuity with the previous one. Sometimes there could have several instruments for the endogenous variable, and to find the best for x, we choose a linear combination that is the most likely correlated with it. The estimator is called the two-stage least square. The first stage designates the regression made to obtain the fitted value, and the second stage refers to the OLS regression to estimate alpha and beta, because when we use x star instead of x, there is no endogeneity problem anymore. In conclusion, when there is endogeneity, the OLS estimators are not reliable and it's better to use 2SLS estimator. Other methods can also be used to reduce endogeneity, like using fixed and random effect, matching method, regression discontinuity design, and difference estimator. We will conclude by an example of endogeneity in finance. In 1997, after having control of some individual and village filter, Deepa Narayan and Nan Prichet tested the effect of the social capital on the level of individual expenditure. Nevertheless, the causality between the two variables was not clear, and the variable could have been determined by a set of unobserved other variables. To overcome this problem, the scientific decided to use instrumental variables like the level of consumer confidence for the social capital. With the new model, the results show the positive impact of the individual social capital on the measure of the expenditure per household. It's the end of the short video about exogeneity. I hope it gives you some clarification, and thank you.